Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Vanessa, and I am your host for episode 15 called Chemistry of Rockets and Spacecrafts. Today, I will be discussing how rockets are launched into space and how people are able to survive in the spacecrafts. Specifically, how chemistry helps make space travel possible. Okay, so something that I often get confused about is what a rocket actually is. And so a rocket, like what you probably think of, is like the tall, thin, round vehicle that launches into space and explores space. But that isn't actually what a rocket is. It's not just like that traditional spacecraft. So a rocket is actually defined as like the engine that the rocket uses. So anything that uses like that engine or a similar engine would be considered a rocket, which is how you get like fireworks are technically rockets. The first rockets were invented in China in the 1200s, and they were fireworks. They used solid fuel and were often used as either for like entertainment, like how fireworks are. So like if you've ever been to a fireworks show, they like shoot up into the air and they explode, and that's actually the same type of like engine, I guess. It's not really like an engine, but like the same type of fuel that is used to like launch rockets into space. It's a little different, obviously. It needs to be much more powerful, and there's a lot more like science behind the rocket ones, obviously, like engineering. But basically, so they were originally used as fireworks and flares by armies, and then over time, the rockets evolved and became bigger, and the rocket production really picked up during the Cold War. In 1957, the Soviets launched Sputnik, which began the space war, or the space race, not space war. And in 1969, the United States sent the first man to the moon with the Apollo missions, and they did that with the Saturn V rocket, or the Saturn V rocket. So something really cool about the Saturn V rocket is that when I went to Houston, NASA, they actually had one of the unlaunched Saturn V rockets. I'm not really sure why. I forget why it didn't launch, but it was really cool to see. Like, they had it kind of taken apart, so you could like not go inside it, but you could see where the engine was, which was pretty cool. And it's huge, by the way. Like, I mean, obviously, like seeing it on TV, like it looks like big, like it's big, but just seeing it in person was so cool. So I definitely recommend, if you ever find yourself in Houston, to go to NASA. So as I said before, rockets and spacecrafts, how they've worked and just how they've looked, obviously have changed a lot over time, especially with the types of engine used and how the engines work. So the type of engines used during like the shuttle missions, and then like with the space capsules of Apollo missions, they adapted and like changed for the better over time. And with the engine that's going to be used for the Artemis missions coming up also are very different, or not very different, but pretty different from what was used originally. So how do these engines actually work? So I will be going into more detail about this a little later from like a chemistry standpoint, but basically the engines burn fuel, which turns into hot gas, which is then pushed out the back by the engine. The gas causes the rocket to propel upwards and move forwards. And then a rocket engine is different from a jet engine because it doesn't need air. So everything that a rocket engine has is already like within it, everything a rocket engine needs is already within like its engine, which is what allows it to work in space. Like, it doesn't need to use the air around it like a plane engine does. So there are two types of engines that are mainly used. So the main one that is used a lot in like space missions are liquid fuels. It's used in the space shuttles. It was used for the Russian Soyuz missions, and the first liquid fuel rocket was that is used today was invented by Robert H. Goddard. So fun fact there. And then there's also solid fuels, which is what is used for like fireworks. It's also on the sides of like the space shuttles, or on the sides of like the rockets also, just kind of more propellant. So today there are 3 main missions that the U.S. partakes in. So there's the ISS, or the International Space Station, which consists of astronauts from NASA, Russia, Japan, Europe, and Canada space programs. And their goal is to conduct research and study space, so they spend a lot of time on space. And I will go into how that is even possible, because there's no breathable oxygen or air in space. So I will go into more detail about that a little later. There's the Artemis missions, which are coming up. The first one launched a few months ago. Their goal is to return to the moon, a long-term presence on the moon to study and better understand the lunar surface, and to just, get to understand, like, the planets in our solar system a little bit better. And then there's the SpaceX mission, which aims to help in the mission to colonize Mars and participate in space travel and exploration. And now for the chemistry. So what makes NASA rockets fly? So, short story short, which I think is really cool, it's a combustion reaction. So basically, like physics is involved a lot in rocket launches. Like there's Newton's third law, which states that for every action, there's an equal and opposite reaction. And the combustion reaction allows the rocket to launch and then fly. And if you don't know what a combustion reaction is, it basically results from burning something, and it produces like water or steam and carbon dioxide. So basically it releases energy, which then allows the rockets to move, and the fuel that is burned to create the reaction is then mixed with an oxidizer, which creates propellant. So basically the main engine is the RS-25, and it is a liquid engine. So it consists of liquid hydrogen as the fuel, liquid oxygen as the oxidizer, and the booster, which use aluminum as fuel with ammonium perchlorate as the oxidizer, and it is mixed with a binder, creating a homogeneous solid propellant. So hydrogen is the main fuel, and it is used because it is the lightest element that exists normally as a gas. And it also has a very low density as a result, which means that it takes up a lot of space, which can be very problematic when you're trying to have a spacecraft that can fly and be aerodynamic, in space. Because it would need a huge tank to hold the amount of fuel, hydrogen gas that it would need for the combustion reaction to occur. So as a result, they cool the hydrogen to negative 432 degrees Fahrenheit, which will turn it into a liquid and make it much more denser, meaning it takes up a lot less space. So it makes it able to be brought into the engine, and they don't have to have a giant clunky engine, which would be really hard to make, as I said, aerodynamically suitable. And then they do a similar thing to oxygen, because oxygen, although it's much more denser than hydrogen, it also needs to be compressed into a liquid in order to fit into the smaller and lighter tank. And to do that, it is cooled to negative 297 degrees Fahrenheit. So the main reaction that occurs is 2 hydrogen molecules plus 1 oxygen molecule results in 2 molecules of water and a lot of energy. So basically it just produces water. So the steam that you see is literally just steam, and that is what propels the spacecraft or rocket upwards. The hydrogen-oxygen reaction generates heat, which causes the water vapor to expand and exit the nozzles at speeds of 10,000 miles per hour, which is insane, especially when you consider that it's literally just steam. There's not some special, chemical in it making it go really fast and, really high, which I think is really fascinating. and the fast-moving steam allows the rocket to propel upwards. So as a kid, I had no idea how rockets like launched. Like I thought like it was like manually controlled, you know, like a toy plane, or that it was like, I didn't even think that it could be a chemical reaction. I mean, obviously as a kid I didn't really know physics, but like when I took physics last year, I was like convinced. I was like, it's just physics. Like I didn't know that there was chemistry involved in rocket launches. So it was pretty cool to learn that there was actually a lot of chemistry involved. Like a rocket could not launch without a combustion reaction. My friend was telling me that they thought that rockets launched, they were kind of on a trampoline until they went up. And I thought that was kind of funny. So now that I've talked about how the rocket actually launches, I'm going to talk about what actually happens when you're in space. Like how do the astronauts, how are they able to, live in the space stations or like in wherever they are, like the capsules or the ships? Like how are they able to breathe without a suit on? Like you see the videos of them and they're like demonstrating stuff, but they don't have a suit on. So I was always curious how are they able to breathe, because there's no breathable air in space. So the International Space Station uses a method to remove carbon dioxide from the air and allow astronauts to breathe by using a sorbent, which is lithium hydroxide. And if you didn't know, by the way, lithium hydroxide is a very strong base. And so basically the exothermic reaction of lithium hydroxide with carbon dioxide creates a solid lithium carbonate and water. And the lithium hydroxide has a high absorption capacity for carbon dioxide, so it produces a small amount of heat. This will also be used on future missions to Mars, as well as other long-term missions that require people to be able to breathe without their suits on, since, so it's an acid-base reaction pretty much. So the lithium hydroxide is able to absorb the carbon dioxide in the air, allowing people to breathe. And the reaction for that is 2 lithium hydroxide solid plus carbon dioxide gas results in lithium carbonate solid and water gas or water vapor. As I said, it's an acid-base reaction. There are scrubbers, which are expandable filters that contain the lithium hydroxide to capture the carbon dioxide. And this is what removes the carbon dioxide from the air and, as I said, allows the astronauts to breathe. For like super long-term missions, this isn't super effective because the scrubbers, like the lithium hydroxide, has to keep being replaced. So a newer method is that they have minerals called zeolites, which are used, and the zeolites capture the carbon dioxide and release it into space, which allows them to be reused for extended periods instead of just like absorbing the carbon dioxide and keeping it inside until it can't have any more in it. So more recently, scientists have discovered a way to actually turn carbon dioxide into water and breathable air. So basically, carbon dioxide is a reduction system, which means that the number of electrons associated with the atom increases. And this is kind of what allows it, when combined with hydrogen gas, to form water and methane. Not allows, but this is what occurs when it is combined with hydrogen gas. So the methane gas is then vented into space, and the water is split into breathable oxygen and hydrogen gas using hydrolysis. And hydrolysis pretty much is just like creating water or breaking down water. And the hydrogen gas is then used to make more water. So I think this reaction is probably like really cool, because what's going to allow like astronauts to breathe in space and then also to produce water in space is like just something that once it starts, it can just keep going, because it'll just keep producing more hydrogen gas, which will keep reacting with the carbon dioxide that's in space and producing water and breathable oxygen, and it'll just keep repeating. And I think that's really cool, like that they were able to figure that out, and then that like it's able to happen like kind of spontaneously. And so, yeah, that's the chemistry of how rockets are able to launch, and then how people are able to actually breathe in them and in space without their suits on. And now I'm just going to briefly talk about like why I chose this topic. So space has always been something that has like fascinated me. I grew up obsessed with everything like space and NASA related. I would drag my dad to like watch like meteor showers or like try and see a comet. And like I still remember the first time I ever saw like a shooting star. Like I almost cried, to be honest, because I'd been trying so hard to see one, and I, for whatever reason, like it was too cloudy or something, and I always missed it. And so, like, I just love learning about, like, what NASA discovers about, like, Jupiter or, like, Pluto or, like, another galaxy. But I've never really, like, learned a lot about rockets. I mean, I knew, like, physics was applied to them, as I said, but I didn't know there was chemistry involved. And I just didn't really know a lot about, like, the stuff that actually allows us to be able to get, like, data from astronomical bodies. So I wanted to research this topic to learn exactly how rockets work, specifically on a chemistry level. I have visited the Air and Space Museum in DC, which I definitely recommend if you ever find yourself there, because it does talk a lot about how the rockets work. I think it has one of the Apollo capsules, which is really cool to see. It has like spacesuits, and it does talk a lot about like how they make the food like able to like survive, or not survive, but like remain like good to eat in space. And then, as I said before, I've also been to NASA Houston, which I highly recommend. That was so cool. There was a Mars rock you could touch. And then obviously Cape Canaveral. I really want to see a rocket launch, and now that I know that there is no like toxic chemicals involved in the actual launching, and it's really just steam that's being produced, I can hopefully go with a little bit less nervousness about getting like some poisoning from the launch. And yeah, I really hope someday I'm able to see a rocket launch, especially now that I know like that it's just a combustion reaction, which I've learned about in chemistry. Like that makes it launch. Like I think that'll just be really cool being able to like know like what is actually allowing this rocket to launch. And yeah, I just think it's really cool to learn how chemistry affects something I love so much as space. Thank you for listening to this episode of Chemistry Connections. For more student-ran podcasts and digital content, make sure you visit www.hvspn.com. Thanks. Bye.